Hello, welcome back guys. So in this lecture, we'll be quickly talking about the performance of the array. Okay, so in the last lecture, we have seen through the lens of big O, what is the performance of an object if we work with the object. Okay, so first thing, why we need array. So let's say the order in the data does matter. If you want to store something in a data structure where the order does matter. Okay, or in simple words, if you want to store the data in order. Okay, so in that case, array can be the best option. I know it's not like the only option in the data structures, but this is the built-in one. So array is also one of the best option to store the data in sequence. Okay. Later in the series, we'll be learning about a few more data structures which are quite more efficient than arrays. Okay. But if you store the data in sequence in array using array, then it also obviously comes up with some cost, right? So here, as you can see, like big O in the array, I have already mentioned something here. Let me quickly zoom in. Right. So as you can see, like insertion in the array, it depends like where you are inserting, whether you are inserting in the beginning of the array or whether you are inserting at the end of the array. Okay. We'll discuss about this in a minute. Okay. And then removing, same thing, like what will be the big O of the removing of the element in the array. Right. So it also depends like whether you are removing the element from the beginning of the array or whether you are removing the element from the end of the array. And then we have searching. Searching is always O of n in the array. It's not exactly O of n. It's roughly like O of n, right? Because we worry about the broad trends, right? Big picture only. Because it could be like O of 2n, O of 0.5n. It can be anything. But roughly it will be directly proportionate to the size of the input, which is n, right? So we consider it as O of n. And then accessing is like as fast as we have in the object, right? So now let's see what are these one by one. Okay, so I have an array here. Okay, so let's discuss here itself. Right. Let me quickly stretch it so you guys can see my complete screen, right? Because we don't need this one right now. Okay. So as you know by now, like array stores every data in some index, right? So let's add some space. Okay, so I think let's remove these two because these are numbers, right? So you will get confused like if I store the index. Okay, so let's say we have an array of these data, right? Where we have 4 elements. So first one will be stored in the index of 0, right? And then second one, so annoying to write like this, will be stored in the index of 1, and then third one will be stored at the index of 2, and then fourth one will be stored at the index of 3. Okay, so let's say you wanna store something at the end of the array. Okay, let's say you have stored Simon. You got a new element, you have to push it at the end of the array. Then as you can see, it is not impacting our array at all. The indexes will remain same, right? It's just don't have to worry about what is the size of the data. So inserting at the end of the array is always O of 1, right? Because it will be as fast as like inserting the data in object. Okay, so here comes the index number 4 because it doesn't have to look at the rest of the elements in the array. Okay, so same thing like removing the element from the end of the array, it is also O of 1 because if I remove it from here, okay, so it's not gonna impact the rest of the array, right? Because it doesn't have to worry about like the size of the array. Okay, so this way removing and adding the element at the end of the array is always O of 1. Is not like exactly O of 1, is roughly O of 1. Okay, now Now let's talk about the adding the element at the beginning of the array. So let me show you guys like what will happen if you add some element at the beginning of the array. So let's say I wanna insert some element. Let's name it as Raj. Okay. So as you can see, the moment when I inserted the element Raj, all the indexes got messed up, right? So what will happen, what array have to do now is like it have to again re-index every element, right? See, now it will assign the Raj the index 0 like this one, and then Raunak the index 1, this boolean value the index 2, and then this object the index 3, and then this Sam as index 4, right? So this way, like this is a small array, right? So we doesn't care about the performance, but just think about the array which have thousands of elements, then it can create a huge impact there, right? So adding and removing at the beginning of the array can affect the performance of your code, right? So I'm not saying like you should completely avoid adding and removing elements at the beginning of the array, because in some cases it is a need of your scenario, right? So I just wanted you guys to be aware of this thing, like how it affects, like performance wise, how it is going to affect your code. Okay. So yeah, so right now I have added an element at the beginning of the array. Okay. So we have rearranged all the indexes, like JavaScript will rearrange the index of all the rest of the elements. Okay. So now if we remove it from the beginning of the array, then again the indexes got messed up, right? So now again this Raunak we have to assign index 0, and then this element we have to assign index 1, and then this element we have to assign index 2, and then this element we have to assign index 3. Okay. So this way the time complexity of inserting and removing elements from the beginning of the array is roughly O of n. Okay. So that is why I was saying like inserting and removing depends on the situation, like where you are inserting the element. Okay. And same will happen like if you insert some element in between the array. Okay. So down the road, like in the series, we have some other data structures which are similar to arrays, where you can store the data in order, but will be quite performant than the arrays. Okay. So now let's talk about the accessing the element. Okay. So there is a lot of misconception in most of the beginners. Like they think like, let's say we have 1000 elements array, right? So if we try to access 999th element with its index, then it is going to take a lot of time. Like it's gonna take O of n time complexity, right? But it's not the case. It's not gonna count every element one by one, and it's gonna find the index which is 919, whatever I just said, and then it will give you the element. It's not like that. You gave an index to the array, it will directly jump into that index, no matter what the size of the array is, right? Okay, so it will quickly jump into that index. If there is any element, well and good, it will return you that element. Otherwise, it will give you undefined, right? It's simple as that. So time complexity of the accessing of the element in the array using its index is quite efficient. It is O of 1 always, no matter what the size of an array is. Okay. So now let's talk about the searching of the array. Okay, searching of the element. Let's say you want to search some element in the array. Let's say you want to search for Sam. Okay. Then what will happen, like in array, like at least with built-in methods of the array, what will happen? It will check all the elements one by one, right? And then wherever it finds the element which you are looking for, then it will give you the index of that element, in case if you're looking for the index of that element. Okay. So this way it's roughly proportionate to O of n searching, right? So this is the big high level overview of the array. What's the performance of the array? In the next lecture, we'll be looking at few of the built-in methods in the array, like how we can see it through the lens of the big O, like performance wise, which method is best, which method is not that good. Okay, we can't say like all the methods are bad. Okay, so we'll basically check the performance of all the almost all the methods which are available in the arrays, right, in the next lecture. Okay, So this is it for this lecture, guys. See you in the next one.